And hey, welcome you math students, high level. Exercise or section 2.2, composition of functions. You guys did a pretty good job from looking at your work. Most people got at least through the first half of it. So I'm feeling like you have a pretty solid base. So rather than spending too much more time, let's just do one more problem. Tough problem. It's 14. It's part B, okay? I tried 14 part A is like really tough to find the range. 14 part B is a little more within our area. So let's take a look at this, and if you can solve this problem, understand it, don't worry about doing other ones. If this is giving you a lot of trouble, then do some of the easier ones as well. Just kind of see where you're at with this. So 14 part B, we have two functions, f of x and g of x. One of them has a fraction, one of them has a square. And we want to find g of f of x. So the first thing I want to remind myself of, I'm going to rewrite this in a more intuitive way. Remember, when you have it written like this with a little dot, that really means g of f of x. Actually, I'm going to write that part. So I'm going to do the f of x first, and then I'm going to insert it into the g of x. And this question wants me to find the domain and the range. So let's start with the domain. The domain is, before you find the domain of the composed function, of the final function, you have to start with the inner function, f of x. And you have to determine if there's any restrictions on f of x. So f of x is 1 over x. Now, if you remember, there's two things you're looking for to find out if there's restrictions. You're looking for one, is there a fraction with the x in the denominator, which there is. So since this is just x all by itself, I have a restriction right away. X cannot be 0, right? X cannot equal to 0. Because if x is 0, I have 1 divided by 0. We can't do that. Done. And then the other case is there a square root? Now, in this case, there is no square root, so I don't have to worry about it. But just remember, if there's like square root of x, then in that example, x couldn't be negative. So x would be, greater than or equal to 0. Can't be less than 0, because we can't do negative square roots. So that's your domain check for the first function, the inner function. We don't have to check the outer function, just the inner function. And the reason we're doing that is because once you compose these two, let's do that right now, let's compose them. F of x is going to go inside of g of x. So I'm going to take 1 over x and insert it into that x. Think of that as like a container, right? It's not the same x. These are two different x's. So I'm just going to take that g of f is going to be 10 minus, and then I'm going to stick f of x into that x, and then I still have to square it like that. So this is my new function. This is after I've composed the two. And so what's that going to look like? 10 minus 1 over x squared, right? Because I'm going to take that square and square 1 and square the x. So this is my new function. Now, when you look at this, are there any restrictions in the domain? And if you think about it, if x is 0, then 1 minus 0 is a problem. Can't do that. But x can be anything else. So that original restriction that we found is still valid. Now, if it wasn't, for some reason, let's say that x squared was gone, you would still have to keep that restriction in your final answer. So just keep that in mind, because sometimes when you compose the two functions, the original restriction seems like it's not valid anymore. It doesn't matter. But you have to remember that in order to get to the composed function, you start with the original. So if there's a restriction in the original domain, you need to hold on to that restriction in your final answer, even for your composed function. So the domain here is going to be x is an element of all real numbers except it can't equal 0. It's cool. So now how do you calculate the range? That's a little trick here. So we have this function, 10 minus 1 over x squared. We've got to think about it a little bit to find the range. Remember what's happening with the range. The range is going to be, we're plugging in x's, the function's spitting out y's. So if you look at this, if x is 0, that's off limits. So I'm not going to worry about that one. I'll draw like a little graph. So when x is 0, this function's undefined. There's no y at all. So what's happening close to 0? Well, let's start when x is 1. When x is 1, that's 1 over 1. That's 10 minus 1. That's 9. So when x is 1, y is up here at, like, say, 9. And then when x is 2, 2 times 2 is 4. That's 1/4. That's 10 minus a fourth. That's like 9.75. So now it's going to get a little bit smaller, right? When x is 1, it's 10 minus 1 is 9. When x is 2, it's 10 minus a fourth. 9.7. That is right, 9.75. So it's going to be a little bit higher. That's cool. Then when x is 3, 3 times 3 is 9. That's 1/9. So it's going to get a little bit even higher. And we could just jump it out to, say, like 100. That's 100 times 100. It's a big number. 1 divided by a big number. This is a really small number. So what's happening is this little part is getting smaller and smaller as x gets bigger. So it's 10 minus a really small number. So if you think of it that way, 10 minus a really small number is going to be very close to 10. So our graph is going to start, and it's going to get closer and closer to 10 pretty quickly, but it will never quite make it to 10 because there's always going to be something there, really tiny something here as x gets bigger and bigger and bigger. So far, so good. And if you think about it, if x was a negative number, it would be the exact same thing because a negative times a negative is a positive. So the other side's going to look the same. Now the question is, what happens here? What happens between x being 0 and x being 1? It's kind of looking like the graph, you might assume the graph is going to dive down. So let's think about it for a minute. If x is like really small, well, what happens between 0 and 1? Fractions, right? Decimals. So it's like 0.5. If x is 0.5, 0.5 times 0.5 is 0.25. 1 divided by 0.25, so it's 1 divided by a decimal. It makes the number get bigger, right? If you forget that, write that in as a fraction. That's 1 divided by 1/4, which is 1 times 4, because we got to find the reciprocal. So what's going to happen is, as this gets smaller and smaller, in between 0 and 1, as they become tiny little fractions, that's going to actually make this thing get bigger and bigger and bigger. And so 10 minus a really big number is going to become a really small number, right? 10 minus 100, 10 minus 1,000. So in between 0 and 1, the y's are going to get really, really small. They're going to become negative numbers because it's 10 minus a huge number. So that means the graph is going to dive way down on both sides. So that's what your range would look like. The range would be y is less than 10. It's never going to equal 10, but it's going to get really, really, really small, and it'll go on basically to infinity. So hopefully that made sense to you. Work it out a little bit. And if you need any more help with the functions, try a few of the other problems. This was probably the hardest one. All right, good luck. Namaste.